When the first humans wandered across the dust-colored plains of prehistoric Africa, long before they carved symbols into bone or felt curiosity stirring in the chambers of their still primitive myths, the ocean was already there, breathing with a rhythm older than any pulse on land, its tides swaying in silent authority as if it were the true heartbeat of the planet. Even then, though they lacked words for it, early humans felt the presence of a boundary between the world they knew and the world they could only imagine, a shifting frontier that glittered under the sun by day and darkened into a vast, unknowable abyss by night. The ocean, to them, was not merely water. It was a moving continent of mystery, a place where the horizon concealed secrets that no footprints could reach. And so, long before the first vessel scraped against a shoreline, or the first oar dipped into a wave, the ocean began its reign over the human imagination. As millennia unfurled, those primal fears slowly mingled with fascination, especially as tribes settled along coasts and discovered that the ocean held both danger and sustenance in its endless folds. Shell middens, still found today, ancient piles of discarded oysters, mussels, and whelks, act as time capsules of humanity's earliest relationship with the sea, whispering of nights illuminated by flickering fires where people cracked open shells and tasted the brine of a world that seemed eternal. With every tide that washed more treasures ashore, their understanding deepened. The ocean was a provider, a destroyer, a force worthy of reverence. In those eras before formal religion, storm clouds gathering across the waves were omens, and the roar of surf against cliffs might have sounded like the breath of an unseen giant whose moods shifted with the moon. Civilizations emerged, and with them the first attempts to map and mythologize the ocean's power. The Sumerians, dwelling in the cradle of Mesopotamia, spoke of a primordial sea goddess named Nemu, from whose boundless waters all creation was believed to have sprung. They imagined the world as a disk surrounded by a cosmic ocean, and although this image seems simplistic compared to modern geography, it reflected an instinctive truth. Humanity sensed that water existed everywhere, beneath everything, shaping continents long before people knew what a tectonic plate was. In Egypt, the mighty Nile flooded each year with clockwork intensity, a reminder that water, whether in rivers or oceans, held dominion over all life. The Egyptians depicted Nun, the watery chaos, as the origin of existence itself, reinforcing a belief shared by many early cultures that the sea was not merely a place on earth, but a memory of creation.
Far to the east, the earliest navigators of the Pacific, ancestors of today's Polynesians, were already reading the ocean with a mastery that seems almost supernatural. Long before compasses existed, they sensed subtle patterns in swells, memorized star paths stretching across the sky, and felt the vibration of waves striking distant atolls or reefs that lay far beyond visible sight. oral histories preserved across thousands of miles of ocean describe canoes gliding through the vast blue desert as if guided by invisible threads, each voyage echoing with chants that merged sky and water into a single map. Their understanding of the ocean was not written in ink, but woven into legend, encoded in rhythm and repetition, passed down through generations who treated the sea not as a barrier, but as a highway older than any empire. Meanwhile, in the Mediterranean basin, the Minoans of Crete were developing another kind of relationship with the ocean, one centered on commerce and power. Their ships, adorned with high prows and strong timber frames, cut through the waters like arrows sent from the hand of a god. They traded pottery, textiles, and precious metals across islands and coasts, their influence spreading so widely that some historians believe they may have been among the first to treat the sea as a political tool, rather than merely a source of food or myth. Their frescoes depict dolphins leaping alongside human swimmers, not as fantastical beasts, but as companions in a shared world, reflecting a society that felt comfortable in the realm where land meets water. Yet even their mastery was fragile. When the volcanic island of Terra erupted around 1600 BCE, unleashing tsunamis and ash clouds that darkened skies, the Minoans were reminded of a lesson civilizations would learn again and again. The ocean can turn from benefactor to executioner in a single breath. The Phoenicians, emerging a few centuries later, elevated oceanic exploration to a new height. From their city-states along the Levantine coast, they launched ships built with cedar planks fitted so tightly that even Poseidon might have approved. They charted routes that wound across the Mediterranean and beyond the Pillars of Hercules, reaching the Atlantic edges of Africa and Europe with an ambition unmatched in their age. The Phoenicians invented the purple dye that would become synonymous with royalty, and they transported it across the sea as if the ocean itself endorsed their enterprise. To them, the water was a network of opportunities, a sprawling marketplace where every wave whispered of distant harbors and fortunes yet to be claimed. While merchants sailed westward, Greek thinkers gazed outward at the sea and began to ask questions that peeled back its mysteries layer by layer. Herodotus, often called the father of history, wrote of strange marine creatures seen by sailors, a blend of truth and embellishment that hinted at the ocean's biological richness long before science could categorize it. Aristotle, observing the teeming life of lagoons and shorelines, produced some of the earliest known zoological writings, describing octopuses, cuttlefish, and fish reproduction with surprising accuracy. His insights, though still framed by myth and misunderstanding, marked the beginning of humanity's attempt to describe the ocean not only with awe, but with empirical curiosity.
Rome took control of the Mediterranean with the confidence of a civilization convinced it could dominate both land and sea. The Romans built ports, lighthouses, and warships that projected power across the waves, but their mastery was limited by a truth that would haunt even later empires. The ocean is too vast for any one civilization to fully command. Storms wrecked fleets, tempests overturned ambitions, and in the end, Rome's relationship with the sea was shaped as much by humility as by conquest. Still, their engineering feats, breakwaters, harbor basins, underwater concrete, laid foundations for centuries of maritime infrastructure. Far to the north, the ocean inspired a different kind of legacy among the Norse. Their longships, sleek and symmetrical, were crafted for speed and agility, carrying warriors whose sagas would echo through time. These seafarers crossed the North Atlantic long before most of Europe believed such a journey was possible, navigating by the stars, the direction of ocean swells, and even sunstones that revealed the hidden position of light on cloudy days. Their voyages to Iceland, Greenland, and eventually the fringes of North America marked one of the most daring expansions of human presence across oceanic expanses, driven as much by necessity and opportunity as by the restless spirit captured in their poetry and lore. As centuries passed, the ocean remained a restless stage where cultures rose and fell, each adding a new layer to humanity's understanding. Chinese mariners during the Han and Tang dynasties mapped coastlines with precision, and by the time Admiral Zheng He set sail under the Ming dynasty in the 15th century, China had built some of the largest wooden ships ever constructed. His fleets carried porcelains, silks, and ambassadors across the Indian Ocean, linking distant kingdoms in a web of diplomacy and commerce. The logs of these voyages speak of storms, exotic animals, towering waves, and encounters with lands that seemed to shimmer with both opportunity and danger. Yet, even as civilizations advanced their techniques, the ocean remained largely inscrutable beneath its shimmering surface. Most imagined that sea monsters lurked in the depths, that whirlpools could swallow ships whole, and that beyond certain horizons lay realms where the world simply ended. Medieval maps illustrated this fear with ornate depictions of serpents and leviathans, symbols of the limits of knowledge rather than accurate portrayals of marine life. The truth that the ocean harbored creatures stranger and more varied than any myth would only begin to emerge much later. When European explorers set out during the Age of Discovery, they crossed oceans not with understanding, but with determination, shaped by ambition, desperation, and the tantalizing promise of lands unknown. Their logs recorded nights illuminated only by starlight reflecting off rolling swells, weeks of drifting through vast patches of sargassum, and storms that tore masts from decks as if the sea were testing the resolve of these intruders. They described flying fish gliding over waves like silver arrows, phosphorescent creatures glowing beneath the hull, and the eerie stillness of doldrums that could trap ships for weeks with no wind. These observations, though often clouded by superstition, also revealed the immense scale of the ocean and hinted at the complexity of its ecosystems.
They sailed into regions where the ocean's temperament changed with bewildering speed, shifting from tranquil expanses of glassy calm to towering swells that rose like dark fortresses ready to collapse onto fragile wooden decks. The Portuguese captains charting the route around the Cape of Good Hope wrote of waves so steep they seemed carved by gods intent on reshaping the earth. Farther west, in the unbroken reaches of the Atlantic, Spanish and later Dutch sailors encountered waters alive with swirling currents, eddies, and patterns they struggled to explain. Long before the Gulf Stream had a name, mariners knew of a warm river flowing within the ocean itself, propelling some ships forward while dragging others hundreds of miles off course. They sensed the unseen forces beneath their hulls, but had no vocabulary for the vast conveyor belts of water that carried heat across the planet like arteries of a living world. As voyages multiplied, the ocean became the stage for cultural collisions that reshaped history. Meeting points of languages, goods, diseases, and ambitions that crossed thousands of miles. Yet for all the human drama unfolding above the surface, the world below remained sealed in perpetual obscurity. Sailors peered over the rails and saw darkness swallowing the shafts of sunlight. They dropped weighted ropes into the waters and found no bottom, even after hundreds of fathoms. Their fear of the deep was not irrational. It was an acknowledgement of ignorance. The ocean's true depth, in every sense, remained beyond reach. Still, curiosity grew. In the 17th century, natural philosophers along European coasts began collecting washed-up coral, shells, and the strange remains of cephalopods that baffled even the most learned scholars. Some believed corals were plants. Others argued they were minerals somehow imbued with life, and none could agree on how such complex forms could develop in darkness. When fishermen brought up bizarre creatures with bulging eyes adapted to murky depths, or bioluminescent organs that glowed faintly even in daylight, these specimens became prized curiosities in the cabinets of aristocrats. They inspired whispered debates about what else might lurk below, and whether the ocean contained an entire universe of life concealed beneath the waves. The 18th century added another layer to humanity's oceanic story through the meticulous observations of scientists like Edmund Halley, who charted patterns of tides and monsoon winds with an accuracy that astonished even seasoned sailors. James Cook's expeditions, though driven by geopolitical motives, returned with detailed drawings of coastlines, reefs, currents, and marine creatures never before seen by European eyes. Naturalists aboard his ships filled journals with descriptions of flying gurnards, giant clams, and coral structures that seemed to defy the boundary between animal and architecture. For the first time, humanity was beginning to accept that the ocean's inhabitants were not mythical aberrations, but biological wonders shaped by environments unlike any on land.
As the industrial age dawned, steam engines replaced sails, and ships gained the power to fight currents rather than submit to them. The ocean, once a fickle master, seemed conquerable. Telegraph lines were laid across the seafloor, linking continents with messages that traveled faster than any courier. But the attempt to understand the depths often yielded reminders of how little was known. Early oceanographers used primitive sounding devices, heavy ropes weighted with cannonballs or iron cylinders, to probe trenches whose depths they could scarcely imagine. Reports filtered back of abysses so vast they defied belief. Yet each new measurement only deepened the mystery. The Challenger expedition of the 1870s marked a critical turning point. For nearly 4 years, this retrofitted warship crisscrossed the global oceans with a singular purpose: to map the seafloor, collect samples, and catalog the life lurking below. The crew dredged up bizarre creatures, sea lilies anchored to the abyssal plains, shrimp with transparent bodies, gelatinous organisms that dissolved on contact with air. They discovered the global pattern of ocean basins, trenches, and mid-ocean ridges, revealing a topography more dramatic than anything visible on land. The expedition's findings filled 50 volumes and laid the foundations of modern marine science. Yet even then, the enormity of the ocean remained humbling. What the Challenger glimpsed was merely a thread pulled from a vast tapestry woven over billions of years. In the 20th century, as world wars erupted and nations sought to control sea routes with unprecedented urgency, researchers developed sonar to detect submarines lurking beneath the waves. This new technology sent pulses of sound into the deep and timed their echoes, inadvertently revealing underwater mountains, rugged canyons, and volcanic ridges stretching across the planet like scars left by ancient titanic forces. Scientists began piecing together a vision of the ocean floor as a dynamic landscape, shifting, cracking, and rebuilding itself through tectonic processes that connected ocean history with the evolution of continents. At the same time, marine biologists pushed deeper than ever before. Divers using early scuba prototypes descended into waters once thought unreachable, encountering a realm where colors shifted, pressure tightened around the body like an invisible grip, and strange creatures hovered among coral structures with movements reminiscent of dreams. Jacques Cousteau, with his pioneering films, brought these underwater worlds into living rooms around the globe, revealing coral forests, swirling schools of fish, and the silent grace of sea turtles gliding through indigo abysses. His work showed that the ocean was not an empty void, but a pulsing, breathing ecosystem composed of innumerable lives intertwined in a delicate balance. But the deeper regions, the Twilight Zone, Midnight Zone, and the Hadal Trenches remained almost entirely unexplored until the advent of submersibles capable of withstanding crushing pressures. When explorers finally descended into the Mariana Trench in the mid-20th century, they discovered life thriving where none had been expected. Translucent amphipods scuttling across the sediment, microbial mats feeding on chemical energy rather than sunlight, and solitary creatures drifting through darkness illuminated only by bioluminescent glows that pulsed like drifting lanterns. Each new discovery rewrote assumptions. Hydrothermal vents, found in 1977, challenged the very definition of where life could originate. At these fissures, superheated water rich in minerals erupted from the seafloor, creating towering chimneys coated with chemical-eating bacteria. Around them clustered giant tube worms with blood-red plumes, white crabs probing the vents with delicate pincers, and eelpout fish navigating a world utterly divorced from sunlight. These ecosystems proved that life could flourish in complete darkness, feeding not on photosynthesis, but on chemosynthesis, chemical reactions powered by Earth's internal heat. The implications were profound, hinting at possibilities for life on distant moons like Europa and Enceladus, where oceans may lie hidden beneath layers of ice. Meanwhile, on the surface, humanity's relationship with the ocean continued to evolve in complex ways. The shipping lanes that crisscrossed global waters carried goods that enabled modern civilization, but they also brought unintended consequences. Invasive species trapped in ballast water, pollutants released from exhaust fumes, and noise that traveled for hundreds of miles underwater, interfering with the communication of whales, whose songs had echoed across basins long before human speech existed. Fishing fleets, armed with industrial technologies, swept across the seas with a ferocity unmatched in history, pulling entire populations of fish to the brink of collapse. Whaling nations hunted leviathans once considered uncatchable, their massive forms rendered into oil that lit lamps, lubricated machinery, and enriched empires. Yet even amid exploitation, fascination deepened. Researchers deployed satellite imagery to track ocean currents, revealing swirling eddies that transported nutrients across vast distances. Marine archaeologists stumbled upon shipwrecks preserved for centuries in icy depths, sunken time capsules containing the relics of sailors whose last sights were the same waves explorers had described centuries earlier. Storm chasers documented how hurricanes drew energy from warm waters, their strength magnified by subtle changes in sea surface temperatures that hinted at planetary shifts too enormous to ignore. Bioacousticians recorded the haunting calls of blue whales, long resonant notes that traveled across entire ocean basins, connecting individuals separated by thousands of miles. Chemists studied the ocean's capacity to absorb carbon dioxide, discovering that it acted as both protector and victim, shielding the atmosphere while becoming increasingly acidic. In laboratories and research vessels, scientists observed how coral reefs reacted to warming waters by bleaching, expelling algae that had provided color and life for millennia. These reefs, once vibrant undersea cities, were fading, leaving ghostly skeletons behind. And yet, the story stretched even deeper. For the ocean was not simply a victim of human influence, but a central architect of Earth's past. Paleontologists studying sediment cores extracted from the sea floor uncovered tiny microfossils, radiolarians, diatoms, foraminifera, that recorded ancient climates like chronicles etched into mineral shells. Their layers told of ice ages, warm periods, mass extinctions, and tectonic upheavals. They revealed that the ocean had once covered even greater expanses of Earth, that shorelines had shifted like drifting thoughts across geological time, and that entire continents had emerged from or sunk beneath waves as slowly as breaths drawn over eons. This understanding inspired new waves of exploration. Autonomous underwater vehicles glided through the deep, capturing images of deep-sea jellyfish, unfurling tendrils that shimmered with light produced through chemical symphonies more intricate than any human-made device. In trenches deeper than the height of Mount Everest, explorers filmed snailfish transparent enough to reveal internal organs gently beating with life, adapted to crushing pressure. These creatures thrived in silence, in cold, in utter darkness, reminders that life's resilience exceeds even the limits our imagination had constructed. Yet with every discovery, new questions surfaced. Why do certain ocean species migrate thousands of miles each year with navigational precision rivaling our most advanced technology? How do deep-sea organisms communicate, reproduce, or hunt in environments where light has no meaning? What secrets lie beneath the layer of water where sound bends, trapping echoes in channels that allow whale calls to travel across whole hemispheres? Each answer widened the horizon rather than closing it, as if the ocean delighted in presenting humanity with puzzles carefully designed to ignite wonder. Even as knowledge expanded, the ocean retained an aura of unpredictable authority, reminding humanity that mastery was an illusion granted only in fleeting moments. Nowhere was this clearer than in the colossal waves that sometimes rose from seemingly calm waters without warning. Rogue waves, once dismissed as sailors' exaggerations, but now recognized as towering walls of water capable of splintering steel-hulled ships in a single strike. Reports from the early 20th century, once archived with skepticism, were revisited with new respect. Accounts of 80-foot breakers surging out of moonlit darkness, of vessels lifted like leaves before being swallowed by black chasms. Oceanographers deployed buoys and radar, uncovering patterns influenced by wind, currents, and overlapping swells that could transform the sea's surface into a battlefield of forces colliding with chaotic precision. The ocean, even in this age of satellites and sonar, continued to wield mysteries not as exceptions, but as integral expressions of its vast complexity. Simultaneously, new layers of the ocean's history were revealed in the deep-sea sediments that formed like slow snowfall over millions of years. Scientists extracted cores that contained microscopic shards of meteorites, volcanic ash from ancient eruptions, and the remains of organisms whose lifetimes coincided with the rise and fall of empires. These sediments served as records of global events, spikes of iridium marking the asteroid impact that extinguished the dinosaurs, layers of red clay chronicling shifts in ocean circulation, and bands of radiolarian-rich deposits signaling warm epochs when marine life flourished. Each core was a vertical manuscript, written by currents, storms, and the passage of time, revealing that the ocean remembers everything the world has forgotten. At mid-ocean ridges, hydrothermal vents and volcanic fissures continued reshaping the seafloor with ceaseless energy. Submersibles documented lava lakes shimmering beneath crushing pressure, molten rock cooling into pillars that fractured and crumbled as the Earth's crust slowly expanded. These underwater volcanoes released minerals that fed entire ecosystems, fostering biodiversity in the most unlikely places. Biologists studying these ridges discovered species that lived symbiotically with bacteria capable of transforming toxic chemicals into sustenance, a partnership so ancient and efficient that it suggested analogs to Earth's earliest forms of life. The ocean floor, far from being static, was a realm of dynamic creation, its unseen processes writing the geological future in basalt and steam. Meanwhile, the surface ocean, where sunlight filtered through turquoise waters, operated as a different kind of engine. Here, plankton formed the foundation of a food web that sustained whales, fish, and seabirds in an intricate web of interdependence. Diatoms adorned with silica shells etched in fractal patterns, rivaling the precision of fine art, drifted in currents with a grace that belied their ecological significance. These microscopic organisms produced a significant portion of Earth's oxygen, a reality unknown to the ancients who linked breath to forests and fields. Invisible but essential, plankton shaped climates, influenced weather systems, and regulated the composition of the atmosphere. Their rise and fall mirrored cycles in currents like the Pacific's El Niño and La Niña, events that altered rainfall, temperature, and storm activity across the globe. The ocean, in this way, was not only the realm of distant depths or roaring waves, but the quiet architect of planetary balance. Whales, those enigmatic giants shaped by millions of years of evolution, navigated these waters with an intelligence that eluded easy definition. The blue whale, larger than any creature that had ever lived, glided through the ocean with movement slow enough to suggest serenity, yet powerful enough to shift thousands of gallons of water with a single beat of its fluke. Their songs, long and resonant, traveled through deep sound channels with astonishing reach, connecting individuals across continents in acoustic pathways more stable and enduring than ancient trade routes. Researchers analyzing these songs detected regional dialects, seasonal variations, and shifts that hinted at changes in migration, breeding, or environmental conditions. The ocean was their home, workshop, nursery, and battlefield. Its dimensions matched perfectly to their monumental design. Meanwhile, sharks, older than forests and more resilient than many species that came after them, continued their silent patrols across basins and reefs. Their bodies, refined over 400 million years, mirrored the fluidity of the medium they traversed. Contrary to their fearsome reputation in modern media, sharks were among the ocean's most essential regulators, maintaining the health of ecosystems by preying on the weak and diseased. Their role echoed across food webs, influencing the behavior of fish populations and even the distribution of seagrasses. Scientists deploying tracking devices discovered that some species embarked on migrations so long they stitched together ocean basins with routes spanning thousands of miles. Journeys guided by magnetic fields, water chemistry, and instincts coded through epochs. Coral reefs, vibrant tapestries woven from tiny polyps that built limestone fortresses over centuries, teemed with life that dazzled even the most seasoned researchers. Schools of fish moved together in synchronized choreography, darting through crevices shaped by tides and growth cycles that recorded centuries of history. Reefs acted as living archives of water quality, temperature shifts, and ancient storms, their patterns as intricate as fingerprints. Archaeologists studying sunken harbors found corals grown over ancient anchors and amphoras, entombing relics of human activity within biological time capsules. Yet reefs also bore the scars of recent upheavals, bleaching events that stripped them of color, leaving skeletal frameworks where bustling communities once thrived. In the polar oceans, an entirely different narrative unfolded. Beneath the frozen surfaces of the Arctic and Antarctic, waters pulsed with nutrient-rich currents that fueled some of the most productive ecosystems on Earth. Krill swarmed in unimaginable densities, forming living clouds devoured by whales, seals, and seabirds, whose survival hinged on this vast reservoir of microscopic life. In the perpetual twilight beneath the ice sea, algae grew in delicate webs that clung to the ice undersides, providing energy for complex food chains. The freezing and thawing of ice acted as a heartbeat that regulated global circulation, driving thermohaline currents that carried warmth and cold around the planet like blood in a planetary vascular system. As technology advanced, satellites orbiting hundreds of miles above the Earth measured ocean color, surface temperatures, and the rise and fall of tides with precision unimaginable in earlier centuries. These observations revealed patterns of swirling vortices, eddies that spun off major currents and acted as crucibles for nutrient mixing. They captured the fractal complexity of coastlines, shaped by tides, storms, and tectonic uplift. They traced the shifting boundaries between warm and cold waters, patterns that determined the migration of marine species and influenced the intensity of monsoons. For all its apparent simplicity from the deck of a ship, the ocean was revealed to be a vast mosaic of interconnected systems, each influencing the others across scales from microscopic to planetary.
Deep-sea canyons carved by ancient rivers long before sea levels rose, sliced into continental shelves, their walls cloaked in sediments carried by landslides and turbidity currents that raced along the seafloor like avalanches in slow motion. These canyons served as conduits for nutrients, carrying organic material from coastal zones to the deep ocean, where it settled into layers that preserved the story of Earth's climate across millions of years. Submersibles exploring these canyons encountered octopuses gliding through darkness with movements so deliberate they appeared almost contemplative, and fish with tubular eyes adapted to detect the faintest glimmer of bioluminescent prey. Every descent into a canyon revealed new species, some transparent, others armored, all shaped by the intense pressures of a world without sunlight. Meanwhile, the ocean's chemical composition told its own story. Salinity fluctuated with rainfall, evaporation, and the melting of ice, creating subtle differences that influenced density and circulation. The balance of dissolved gases dictated the survival of countless species. Oxygen minimum zones expanded and contracted based on productivity, climate conditions, and currents. Scientists measuring these zones found patterns that reflected both natural cycles and the growing influence of human activity. An influence inscribed not only in atmospheric changes, but in the very chemistry of the sea. Even the soundscape of the ocean evolved. Hydrophones lowered into the deep recorded the crackling of snapping shrimp, the long-distance calls of whales, the drumming of fish defending territory, and the rumble of underwater earthquakes echoing through miles of water. The ocean was not silent, but alive with communication, conflict, and motion. Yet these natural symphonies competed increasingly with the roar of ship engines, the thud of sonar pulses, and the metallic groans of industrial activity. In some regions, ambient noise had doubled or tripled within decades, altering the behavior of species that relied on sound for navigation and reproduction. And still, despite all advances, the ocean offered reminders of its vastness through phenomena like internal waves, giant undulations occurring not on the surface, but deep within the water column, where layers of different temperatures and densities interacted. These internal waves, some larger than skyscrapers, rolled silently through the deep, shaping nutrient distribution and influencing currents in ways barely understood. Their discovery challenged assumptions about vertical mixing, revealing that the ocean's interior was far from static. It was a place of movement as dramatic and consequential as any storm above.
As researchers probed these deeper layers, they uncovered another phenomenon of staggering subtlety: marine snow, a continuous drift of organic particles descending from the sunlit surface to the abyss. This gentle shower, composed of dead plankton, fecal pellets, fragments of gelatinous organisms, and microscopic detritus, served as the primary food source for countless deep-sea creatures. The ocean floor, blanketed with this slow rain of decay, became a realm where life persisted not through abundance, but through efficiency. Each organism shaped by the need to extract sustenance from the faintest trickle of nutrients. Ancient corals, some thousands of years old, grew slowly in these dark environments, their skeletons accumulating chemical signatures that recorded variations in ocean circulation and temperature across centuries. Their survival, patient and unhurried, provided a stark contrast to the rapid fluctuations of surface ecosystems. Meanwhile, the interplay between the ocean and the atmosphere continued to sculpt the planet's climate with quiet authority. Evaporation from warm waters fueled the formation of clouds and storms, while the release of latent heat during condensation powered hurricanes that swept across coasts with destructive force. The ocean absorbed vast amounts of solar energy, storing and redistributing heat through currents that acted like conveyor belts, transporting warmth from equatorial regions toward the poles. These processes regulated not only local weather, but the broader rhythms of seasons, monsoons, and atmospheric circulation patterns that had guided agriculture and livelihoods for millennia. Every breath of wind, every shifting cloud front bore the invisible influence of oceanic forces operating on scales too large for human perception. In continental margins, submarine groundwater discharge provided yet another clue to the ocean's intricate interactions with land. Freshwater springs, hidden beneath the waves, released streams of mineral-rich water that altered coastal ecosystems in subtle ways. Ancient cultures placed mythic significance on these underwater springs, believing they were the domain of deities or gateways to the underworld. Modern science, equipped with sensors and submersibles, revealed that these springs supported unique habitats where organisms adapted to gradients of salinity and temperature. The boundary between freshwater and saltwater became a dynamic frontier, shaping the distribution of species and influencing nutrient exchange. Underwater archaeology flourished as exploration techniques advanced. Side-scan sonar, remotely operated vehicles, and photogrammetry allowed researchers to document shipwrecks with unprecedented detail, revealing wooden hulls preserved for centuries in oxygen-deprived waters. In the Black Sea, entire vessels from the Byzantine era lay intact, their cargo undisturbed, their timbers unrotted, their decorations still echoing the craftsmanship of sailors who had perished long before their stories could be written down. Deeper still, ancient forests preserved beneath sediment told of times when sea levels were lower and coastlines stretched far into what was now open sea. These buried landscapes, frozen in time, carried pollen, seeds, and the remains of animals that once roamed across plains, now submerged hundreds of feet below the waves.
In the tropics, vast seagrass meadows and mangrove forests formed ecological sanctuaries that anchored coastlines against erosion. Their root systems trapped sediment, preventing it from smothering corals and providing nurseries for fish that would later journey into open waters. These systems, overlooked for centuries, proved to be among the most effective carbon sinks on Earth, storing organic matter in deep anoxic soils that accumulated slowly over millennia. Their preservation became a key to understanding the ocean's role in stabilizing the climate, revealing a delicate balance between ecosystems that existed at the threshold between land and sea. As scientists studied the migration patterns of marine animals, they discovered that many species relied on cues imperceptible to humans. Sea turtles used magnetic fields to navigate across entire ocean basins, returning decades later to the same beaches where they had hatched. Salmon detected chemical signatures in rivers that guided them back to their natal streams, even after spending years in oceans thousands of miles away. Eels, whose life cycle remained mysterious for centuries, traveled from distant freshwater habitats to the Sargasso Sea, a region of calm waters encircled by currents where they spawned in depths that human eyes had never seen. Their larvae drifted with currents for months before beginning their journey toward continents they had never visited, completing a cycle as old as the species itself. Glow-in-the-dark creatures, once the stuff of folklore, emerged as some of the ocean's most fascinating inhabitants. Bioluminescent organisms used chemical reactions to produce light that pulsed in mesmerizing displays. Lanternfish released shimmering signals to confuse predators. Comb jellies refracted light in waves of rainbow brilliance. And deep-sea anglerfish used glowing lures to attract prey in the eternal night. Marine snow glinted with tiny sparks where bioluminescent bacteria colonized decaying organic matter. The deep ocean, though devoid of sunlight, was far from dark. It glittered with an alien radiance produced by life forms using chemical energy to communicate, hunt, and survive. As humankind continued its restless pursuit of understanding, oceanographers developed increasingly sophisticated models to simulate currents, salinity, temperature, and nutrient flow. These models illuminated how interconnected the world's waters truly were. A disturbance in the Pacific could influence rainfall in Africa, temperatures in Europe, and hurricane intensities in the Atlantic. Even the melting of polar ice, accelerated by shifts in atmospheric composition, altered the density of seawater and threatened to disrupt circulation patterns that had remained stable for thousands of years. The ocean, it became clear, was not simply a collection of separate basins, but a living network whose pulse shaped the destiny of the planet. Monumental underwater landslides provided another reminder of the ocean's dynamic forces.
The Storegga Slide off Norway, one of the largest known submarine landslides, released billions of tons of sediment in a sudden collapse around 8,000 years ago. The resulting tsunami surged across the North Atlantic, reaching the coasts of Scotland and reshaping shorelines in an instant. Sediment cores preserved the fine layers of disturbed deposits that bore silent witness to the magnitude of the event. Similar landslides, triggered by earthquakes, gas hydrate destabilization, or oversteepened slopes, continued to remind researchers that the ocean harbored geological hazards of immense power.
In tropical waters, atolls formed from the slow subsidence of volcanic islands. Charles Darwin, during his voyage on the HMS Beagle, puzzled over the structure of these reef systems. He eventually proposed that fringing reefs developed around volcanic islands, which gradually sank under their own weight or due to shifting tectonic plates, leaving behind ring-shaped barriers that encircled central lagoons. This theory, later confirmed through drilling and seismic studies, demonstrated how biological and geological processes intertwined to create some of the most stunning formations on Earth. Each atoll was a monument to time, measured not in years, but in epochs, sculpted by polyps, building their limestone towers grain by grain. Across the ocean floor, manganese nodules, metal-rich spheres forming over millions of years, littered vast expanses of sediment. Their growth, driven by slow chemical reactions, provided clues about past ocean chemistry, circulation, and biological productivity. These nodules contained elements crucial for modern technologies, igniting interest in deep-sea mining and raising ethical questions about the exploitation of environments humanity had barely begun to understand. The tension between curiosity, need, and caution became a recurring theme in discussions about the ocean's resources. In the mid-water column, the largest animal migration on Earth occurred every single day. Billions of organisms, zooplankton, lanternfish, squid, ascended from the deep under cover of darkness to feed in the surface waters before descending again at dawn. This vertical migration, driven by the need to evade predators and access food, influenced carbon transport, nutrient distribution, and the behavior of countless species. Researchers using sensitive sonar systems detected these migrations as shifting layers of biomass, rising and falling like tides composed entirely of living creatures. The ocean's heartbeat was not just a metaphor, it was a biological rhythm resonating across entire basins. Farther offshore, swirling ocean gyres gathered floating debris into rotating systems that trapped plastics carried by rivers, storms, and winds. While the ancients had marveled at the Sargasso Sea for its floating mats of golden seaweed, modern observers noted the addition of synthetic materials that drifted among the natural rafts. Microplastics, too small to see without magnification,
permeated the water column and entered food webs at every level. Their presence revealed a new layer of interaction between civilization and ocean, one whose consequences unfolded in ways scientists were only beginning to grasp. In underwater caves, explorers found chambers filled with formations resembling those in terrestrial caverns, stalactites and stalagmites, shaped during periods when sea levels were lower. These caves served as archives of ancient climates, their mineral layers holding isotopic signatures that recorded variations in rainfall, temperature, and ocean chemistry. Divers threading their way through narrow passages documented blind crustaceans and other fauna adapted to pitch-black environments, species isolated for tens of thousands of years. These cave ecosystems, fragile and self-contained, whispered of evolutionary pathways shaped by isolation and time.
As explorers pushed deeper into submerged cave networks, they discovered chambers that seemed to defy ordinary geological logic. Vast caverns filled with water so still it mirrored the ceiling with perfect clarity, creating the illusion of floating stalactites suspended in endless void. In these spaces, where time appeared to stall and sound dissolved into the weight of water and stone, ancient human remains were found alongside the bones of extinct megafauna. These relics, left by travelers who traversed dry cave floors during the Ice Age, revealed migration routes and cultural practices long forgotten. The ocean, having swallowed these landscapes as sea levels rose, had preserved them with austere precision, sealing away stories that resurfaced only through deliberate human descent into the planet's hidden depths. Elsewhere, submarine volcanoes continuously reshaped the boundary between land and sea. In regions like the Pacific Ring of Fire, molten rock erupted beneath the waves, forming new islands or expanding existing ones. Some eruptions were so powerful they boiled the sea, sending plumes of steam into the air and covering the surface with pumice that floated for months. These floating rock rafts, carried by currents across entire ocean basins, became temporary habitats for barnacles, algae, and other organisms that colonized them with unhurried persistence. Marine biologists observed how such rafts acted as vessels for genetic exchange, bringing new species to remote coastlines and influencing ecological patterns in ways barely perceptible at human timescales, but profound across geological ones. Amid these dynamic processes, the mid-ocean ridges continued their slow but relentless expansion. Atop these immense underwater mountain ranges, basaltic lava erupted continuously, adding new crust to the ocean floor. Rift valleys split open with seismic shutters, creating fissures where heat and minerals seeped into the deep. Earthquakes and volcanic tremors rippled outward through water and rock, recorded by networks of sensors that revealed the ocean floor to be a restless frontier. The longest mountain chain on Earth lay hidden beneath waves, its peaks and valleys shaping currents, influencing weather, and acting as conduits for the movement of chemical and biological material. In the pelagic zones above, life adapted to a fluid and ever-changing realm. Swordfish, streamlined as if sculpted by the currents themselves, dove thousands of feet in pursuit of squid, whose bioluminescent displays shimmered like constellations displaced into water. Tuna, built for speed, traversed entire oceans with migrations so vast they blurred the line between individual and ecosystem. Jellyfish, lacking brains but driven by ancient reflexes, pulsed through the water in hypnotic rhythms, their tentacles trailing behind them like ghostly script written across the currents. Some species formed colossal blooms spanning hundreds of miles, responding to subtle changes in temperature and nutrient availability that could transform an empty expanse into a drifting metropolis of gelatinous life.
Human divers entering this world experienced the ocean's shifting moods with visceral immediacy. At shallow depths, sunlight filtered through the waves in golden beams, illuminating coral structures and swirling fish. But as they descended, colors bled away until only shades of blue and violet remained. Then darkness encroached, thick and absolute. Specialized diving suits allowed them to reach places once accessible only to submersibles. But pressure remained a formidable adversary. The ocean reminded each visitor that they were trespassers in a realm shaped by forces indifferent to human ambition, forces that had sculpted its creatures with anatomies foreign to terrestrial assumptions. In the Southern Ocean, colossal waves generated by unbroken winds circled Antarctica with relentless force. These waters, among the roughest on Earth, carried nutrient-rich currents that fueled blooms of phytoplankton so dense they could be observed from space. The feeding frenzies of whales, seals, and seabirds drew life into a flourishing spectacle despite the extreme cold. Emperor penguins, surviving in conditions hostile to most vertebrates, navigated these waters with agility, diving hundreds of meters in search of fish and krill. Their social behaviors, chick-rearing in communal huddles that rotated positions to share warmth, reflected a degree of adaptation unmatched in any other bird species. As the decades advanced, new technologies enabled scientists to listen to the ocean with unprecedented clarity. Long-term hydrophone arrays captured faint rumbles of volcanic eruptions occurring thousands of miles away. the clicking of dolphins communicating in complex patterns, and the nearly infrasonic calls of fin whales whose songs echoed across ocean basins. The soundscape revealed layers of activity that changed with seasons, migrations, and even lunar cycles. Nighttime recordings captured a crescendo of snapping shrimp, whose collective crackling resembled the static of old radio transmissions. Shifts in these acoustic patterns offered clues to environmental changes, helping researchers understand how noise pollution affected species that relied on sound for survival. Ocean color sensors detected fluctuations in chlorophyll concentrations, mapping the distribution of microscopic life that formed the base of food webs. These patterns shifted with eddies, whirling masses of water that trapped nutrients and fostered blooms whose edges drifted like brushstrokes across the surface. Some eddies persisted for months, rotating slowly as they drifted across basins, creating biological oases in otherwise barren expanses. Within these swirling realms, predators and prey danced in cycles dictated by currents, light, and chemical gradients. In regions touched by monsoons, the ocean responded to seasonal winds with upwelling currents that brought cold, nutrient-rich waters to the surface. These pulses of productivity fed entire coastal societies for thousands of years, shaping the economies, cuisines, and myths of cultures from East Africa to India to Southeast Asia. Ancient sailors learned to interpret the sky and sea, predicting monsoons with remarkable accuracy. They launched voyages timed to seasonal winds that carried traders across oceans long before modern meteorology could quantify the forces at play. The ocean's influence extended even into the geology of continents. Sediment carried by rivers settled into deltas where land and water merged. These regions, shaped by tides, storms, and the slow accumulation of silt, supported civilizations that relied on fertile soils and abundant fisheries. Ancient maps of river mouths and coastal plains, though often imprecise, captured the interplay between land and sea as observed by societies whose survival hinged on understanding seasonal floods and shifting sands. Modern studies using remote sensing revealed how deltas migrated, split, and reformed, following the push and pull of currents that sculpted coastlines through cycles of erosion and deposition. Far offshore, the deep scattering layer, a zone teeming with organisms that reflected sonar like a false seafloor, rose and fell with diel migrations. Initially mistaken for the bottom during early sonar experiments, this layer was later recognized as the largest congregation of biomass on the planet. It pulsed upward at night and sank by day, its movement synchronized across billions of individuals in a collective behavior that blurred distinctions between ecology and choreography. Its influence on carbon transport, nutrient cycling, and predator-prey dynamics was so significant that some scientists compared it to the root system of a global forest, invisible yet foundational. As exploration expanded, humanity encountered signs of past catastrophes imprinted in oceanic sediments. Layers of tephra, volcanic ash, recorded massive eruptions whose effects rippled across continents. Slabs of displaced rock marked the footprints of underwater landslides triggered by earthquake-induced shaking or the sudden release of gas hydrates. Microfossils captured abrupt shifts in temperature and acidity that corresponded with mass extinctions. The ocean floor, far from being a monotone plain, contained a chronicle as dramatic as any written history. Its archives spanning epochs and revealing the long-term cycles that shaped life on Earth. Near hydrothermal vent fields, researchers discovered not only thriving ecosystems, but complex mineral formations that rose like cathedrals sculpted by mineral precipitation. These chimneys, some towering dozens of meters high, shimmered with metallic hues, copper, zinc, iron, depicted in colors that shifted with changing viewing angles. Within their porous walls, chemical gradients fostered microbial communities that hinted at how life might have originated on Earth. The interactions between heat, minerals, and microbial activity illustrated processes that had operated for billions of years, echoing the conditions of early Earth when oceans had only begun to teem with primitive life. Elsewhere, in calmer tropical waters, massive boulders lay scattered across reefs, evidence of ancient mega-tsunamis caused by volcanic collapses or asteroid impacts. These displaced stones, some weighing thousands of tons, rested in positions that suggested forces far beyond ordinary waves. Their presence told of moments when the ocean's power surged into violence so immense it reshaped the contours of entire islands. Yet the same waters that hurled those stones also nurtured fragile ecosystems where butterfly fish wove intricate paths through coral thickets, and sea fans swayed like underwater forests in slow-motion breezes. Across the mid-Atlantic, fracture zones carved by shifting plates stretched for hundreds of miles, creating underwater landscapes of cliffs, canyons, and valleys deeper than any on land. These geological scars shaped currents that influenced the migration routes of turtles, tuna, and whales. Submersibles documented manganese-encrusted rocks, crumbling basalt walls, and trenches where life clung to pockets of nutrient-rich water. These underwater terrains remained largely unmapped, their scale dwarfing even the most ambitious terrestrial expeditions. In Arctic regions, methane hydrates, ice-like structures trapping gas within crystal lattices, lay buried beneath permafrost and sediments. Their stability depended on temperature and pressure, and scientists studied them with caution, aware that changes in climate could release vast quantities of methane into the ocean and atmosphere. These hydrates, shimmering when brought to the surface before rapidly dissociating, represented both a potential energy resource and a geological hazard. Their distribution revealed patterns of past climate fluctuations and episodes of seafloor instability.